Click the bell icon to get latest videos from Ekeeda.
Hello friends, I welcome you all to this video. We are with 6th chapter of microwave engineering, microwave transistors and tunnel diodes. In this chapter so far we have gone through what exactly the microwave bipolar transistors are. That means how the transistors onto the semiconductor platform are helpful for microwave applications. We started with the thorough knowledge of these transistors along with the operating principles, the various configurations we have gone through, and in the previous video we have also seen the power frequency relations of the same. Now let us solve a simple problem onto it. So here for the topic we are provided a problem statement. The problem statement is a certain silicon microwave transistor has the following parameters. We have four parameters denoted as Xc is equal to 1 ohm, Fr is equal to 4 gigahertz, Em is equal to 1.6 into 10 raised to power 5 volt per centimeter, Vs is equal to 4 into 10 raised to power 5 centimeter per second. Determine the maximum allowable power that the transistor can carry. So in this problem statement, it is very clear that the semiconductor material used for the microwave transistor is a silicon material. Now we shall be first of all identifying the given details and we shall be determining the answer for maximum allowable power. So from the problem statement, the very first parameter that has been given to us, we mention that it is represented as Xc and it is in terms of ohms. So this is nothing but the reactance provided to us. So the reactance value is nothing but 1 ohm to us. The next parameter is denoted by F suffix R and is nothing but the transit time cutoff frequency. And this transit time cutoff frequency is provided with the answer value that it is 4 gigahertz here. Now the next parameter is the third one represented as Em, that is the maximum electric field associated with the transistor here. So the Em value is equal to 1.6 into 10 raised to power 5 volts per centimeter. And the last parameter denoted as small vs is nothing but the saturation drift velocity. So this velocity is very important and given as 4 into 10 raised to power 5 centimeter per second here. Now we get back to the problem statement. As per the problem statement, we require the value of maximum allowable power. Now for maximum allowable power the transistor can carry, we denote capital P suffix M, and with the knowledge of the given details and with the formula we write the expression Pm is equal to 1 upon Xc into Ft square. In the bracket we have the multiplication of Em with Vs divided by twice pi, and this bracket is squared here. So we substitute all the values. So this will be 1 upon, it will be 1 into, in the bracket we mention 4 into 10 raised to power 9 for giga to be squared the frequency. Here we have 1.6 into 10 raised to power 5 in multiplication to 4 into 10 raised to power 5. This is divided by 2 pi and the complete bracket is squared here. So this simple calculation gives us the answer 6.48. So as this is the maximum allowable power the transistor can carry, so the power unit is nothing but the watts here. So I outline this answer. So here we are covered with finding the maximum allowable power that a given transistor can carry for the silicon semiconductor material. By the next lecture we shall be addressing the topic heterojunction bipolar transistors. for the applications of microwave engineering. I hope you enjoy the learnings of this subject. For more information, you can subscribe to Ekeeda channel. Thank you.